Okay, can I get somebody to share with the class the answer number 1? Yes? 0, very good. A whole number is divisible by a second whole number if the remainder after division is 0. Mental math, number 2. What's the answer to number 2, class?
24.
Good. What's the answer to number 3, class?
21.
What's the answer to number 4, class?
12.
Easy stuff. Here are the solutions. Okay. Next slide. This is what we're working on today. I'm going to read, since we're making this video for the 7th grade, I'm going to go and read this. What you'll learn: to find multiples and factors and to use prime factorization. New vocabulary: multiple, least common multiple, factor, composite, prime, prime factorization, greatest common factor. Why learn this? You can use factors and multiples to solve problems involving scheduling. Suppose you volunteer every 3rd day at an animal shelter, and your friend volunteers every 4th day. You can use multiples to find the next day when you both will be at the shelter. Okay? Typically, when students are first taught about multiplication, they're taught about skip counting. Do you guys remember that? So if I skip count by 3s, starting at 0, 3, 6, 9, 12, 15, and it continues on. These are all multiples of 3. Okay? It's 3 multiplied by another whole number. So this is 3 times 1, right? This is 3 times 2, 3 times 3, 9, 3 times 4, 3 times 5. So you guys understand what it is, a multiple of 3? It's a number, a whole number times 3. That's a multiple of 3. Understand? Now, let's take a look, because your friend works every 4th day, right? So the multiples of 4 are 4, 8, 12, and 15. But if you notice, they have a common multiple, right? And so the first multiple they have in common is what? 12. Now, if we continue to skip count, there are other numbers that they'll have in common, right? And so students often will list a common multiple, but they won't give the least common multiple. Do you guys understand what least means? It means the smallest in value. We know what a multiple is, right? Okay. We know what it means to be common. Like if you have a friend and you guys both like the same football team, the Denver Broncos, for instance, you guys have a common favorite team. Does that make sense? So here, the first common multiple is 12. Do you understand? 12 is a multiple of 3, 12 is a multiple of 4, and it's also the first common multiple or the least common multiple. Do you guys understand where LCM comes from? The smallest common multiple, the least common multiple. Are we good? Any questions at this point? Okay. Now, a little bit of notation I want you guys to take notice of. Often, least common multiple is written LCM, the acronym, least L, common C, multiple M. And I'm going to talk to you guys about some notation that the book doesn't bring up, but you'll see it on a standardized test. Okay? So, any questions so far? Let's move right along. So this is very similar to the example I just showed you. Let's see if we can figure this out. Scheduling. A fish sandwich is on a school's lunch menu every 6 school days. Spaghetti with meat sauce is on the menu every 9 school days. If both items are on the menu today, when will both be served again? How would we go about this? Kalila. Well, we wouldn't list all the we would list what? We would list the multiples. Okay, so can you guys go ahead and list the multiples of 6 and 9? Start with 6, go up. Start with 9, go up. List those out. So basically skip count by 6, skip count by 9. And what's the first multiple they have in common? Tallulah. What's the first one they have in common? 18. Did you guys get 18?
Yes.
Let's take a look. Here are my here are my multiples. 6, 12, 18, 24, 30, 36, 42. It goes on forever, but I don't need to keep listing them all. I just need to figure out the first one. 9, 18. Well, guess what? I've already got my multiple in common, 18. Now, if you notice, we can see right now, they have another multiple in common, right? What's the other multiple in common they have? 36. But is this the least common multiple? No, this is not the least common multiple. This over here is the least common multiple. Okay, this is a common multiple. It's not the least common multiple, 36. Not the least common multiple. Students will often give that as an answer in this type of problem, but they're wrong. They understand the common multiple part. They don't understand the least common multiple part. Got it? So don't make a mistake. This is an easy concept if you think about what the letters stand for. Okay? Now, the other thing I want to introduce you to is, do you see this notation right here? LCM, parentheses, 6, comma 9. Do you see that? Close parentheses, equal. A lot of times, standardized tests will just show you that. They won't say, in words, find the least common multiple of 6 and 9. They'll just have this. LCM 6, comma 9 equals. And you have to figure out what it equals to. You have to know that that's what the notation is telling you to do. Do you understand? The book doesn't necessarily show that. I'm showing it to you because I want you to be ready when you see, probably be on an SAT, like one of their easier problems. You'll probably see it on a park. Do you understand? And I think you might even see it in Connexus. I think they write it in the assessments this way. Okay? Now, here's what I need you to do. I want you to try and find the least common multiples of these 3 sets of numbers. And try to use the strategy that I just gave you. List out the multiples, skip count, and then find the first one they have in common. There you go, the least common multiple. So if you can't see it, the first one's least common multiple of 4 and 10. Second one, least common multiple of 5 and 7. Third one, least common multiple of 12 and 15. And when you're done, if you could just put your pencils down so I can know who's still working to give them time. And again, I'll let you use the multiplication chart. Okay? Okay, I would say I have about half the students put down their pencils. Can somebody share with the class the LCM for the first one? Somebody I haven't called on yet. Taylor. 20. Somebody earlier today said 40. What did they give me? They gave me a common multiple. Did they give me the least common multiple? No, that's what Taylor just gave us. The least common multiple of the first problem is 20. Are we good? Okay, so I can promise you, if they had a question like this on Connexus, multiple choice question, they would put 20 in there for one of your choices, but they would also put 40 in there. Knowing that a lot of students mess up that way, do you see how they design these assessments? Yes. Okay, so you would feel good about yourself because like, oh, my answer's here, but it would be incorrect. Okay? So let's know this so we don't trip up on those questions. Who's got the next one? Dominic. 35. It's 35. Now, again, using the strategy, if you list the multiples, you'll see the first one, just like in the previous problem, the first common multiple is 35. Now, if you saw this problem and you saw the answer was 35, you might assume that, oh, all I'm doing is multiplying these numbers. Would you be right? No. Because did that work for this one? No. Was 4 times 10, 40? Was that the LCM? No. Okay, so know that that is not the strategy. List them out. Identify the smallest number they have in common. Last one. Do I have a volunteer for the last one? Somebody I haven't heard from yet. Young man, what's your name? Could you repeat it for me? No. Louisa. Could you tell me your answer for this one? What'd you get? 60. Did you guys get 60? Yes. Okay, so let's take a look. There's my answer. And it is indeed 60 is the LCM. Okay, so at this point, I just want to see, everybody feels good about this? If you feel like you got this down, give me a thumbs up. If you feel like you're kind of shaky, give me a sideways thumbs. If you feel like you don't know what's up, just give me a thumbs down. Okay, I would say mostly sideways thumbs and thumbs up. That's good. Okay, I'm going to move on then. Now, I want to talk to you guys about what the difference between a factor and a multiple. So a multiple is the number times another whole number. A factor is if I have a number, what numbers will divide into that number. So let me give you an example. Multiples of 12. Give me some multiples of 12. 12, then what? 24, then what? 36, then what? Okay, those are multiples, but factors of 12. What are factors of 12? Give me a factor of 12, Jayla. 6. 6 is a factor of 12 because 12 is divisible by 6, right? Can somebody give me another factor of 12? Yes, Tori. 2. 2 is also a factor of 12 because 12 divided by 2 gives me a whole number, no remainder. Can somebody give me another factor of 12? Nathan. 4. 4 is also a factor of 12. Can somebody give me another factor? Sophia. 3, very good. Can I get another factor? You guys are leaving out the easy ones. Yes? 1, nice. That was the easy one. There's another easy one. Who's got the other easy one? Yes? 12, right. Now, let's take a look at our definition of factor, and then I want to talk about 2 other words. So a factor is a whole number that divides another number by a whole number with a remainder of 0. Any number is always divisible by all of its factors. So these are all the factors that divide into 12, okay? Now, a composite number is a whole number that has more than 2 factors. Okay, well, first of all, is 12 a whole number? Yeah. Does it have more than 2 factors? Yes. So what type of number is this? Composite. It's a composite number. Now let's take a look at this other type of number. A prime number is a whole number with exactly 2 factors. 1 and the number itself. Okay? 1 is neither prime nor composite. So that is not a prime number. It's not a composite number. Okay? And if we look at number 13, can you share with me the factors of 13? Somebody give me the one of the factors. Yes? 13 is a factor. What's another factor of 13? Adepoju. 1. Are there any other factors? Okay. So 13 only has 2, so it is a prime number. Got it? Any questions so far? Yes? Because if we think about the definition of a prime number, it has 2 factors. Does 1 have 2 factors? Just 1 factor, right? Okay. And here's another one. Is 0 a prime or composite number? No. So to really, 1 and 0, neither of them have 2 factors, right? So neither of them are prime nor composite. Got it? Any other questions?
So for a number to be prime or composite, it has to be greater?
That's one way to look at it, yes. Good, very good. Well, negative numbers, right? You have some negative numbers. You can factor a negative number. So let's adjust our thinking. Yep.
So it's number 1 isn't a prime or composite number because like so many numbers, if you multiply them.
So think about the definition. It has to have 2 or more factors to be prime or composite. Composite is more than 2. Prime is exactly 2. Okay? 1 only has 1 factor, 1, right? You could say 1 in itself, well, 1 in itself is 1. So that's still only 1. Do you understand? Doesn't work. And 0, what are the factors of 0? There's, right? You can't say there's 2. You can't say there's, do you guys understand? And technically, yeah, 0 doesn't work either. Questions? Any questions about this? Okay. Now, can you guys take a look at this number right here? First of all, can I get somebody to tell me what are the factors? Give me the factors for this number. Joshua? Factors of 15. Give me one. 3. Yep. Does somebody have another factor? Trying to remember your name. Go ahead. Nicholas. Yes. Give me another factor. 5. That's another one. Very good. Can I get another one? Talise? 1. Can I get another one? Caleb. Quinn. Go ahead.
Okay. The other factor is 15.
Right, 15. Have we identified all the factors?
Yes.
I think we're good. So now we need to ask ourselves, does this qualify as, well, first of all, is it a whole number? Is 15 a whole number?
Yeah.
Yep. Does it qualify as a prime number? No. Why not? There's more than 2 factors. So it's a whole number that has more than 2 factors. So what type of number is it? It is composite. Okay, more than 2 factors. Any other questions? Yes.
So a fraction can be
Right, that's not a whole number. Has to be a whole number. Okay, moving right along. Now, I'm going to show you a method to get the prime factors, to get the prime factorization. And the reason why I'm going to show you a specific method is because I'm going to give you a strategy to find GCF. Okay, so some of you are going to have other methods and you'll get the same result, but you'll see why I'm going to have you use this method in a minute. Okay, so first of all, we're going to come up with the prime factorization of composite numbers. So writing a composite number as the product of its prime factors shows its prime factorization. This product is unique except for the order of the factors. You can use a factor tree to find prime factors. So in my example, we are going to get the prime factors of 60, and we're going to make a factor tree for 60. Now, some of you guys, if you know how to make a factor tree, go ahead. Your method might be different than mine, but in the end, I want you to compare your result with my result and your method with my method. Okay? My method will work on every single number, and it'll give you the same looking tree, very similar looking tree. Okay? So I'm going to go ahead and start this out. This is 60. That's the number we're trying to get the factors of. Can somebody take a look at these numbers right here? What type of numbers do I have right here? What kind of numbers are these? Sophia?
prime numbers.
These are prime numbers, right? They only have the numbers themselves and one as factors. Now, are these all the prime numbers? No, there are many more larger prime numbers, but these are the first 8 or so, right? I would say for this level of math, you probably don't need to go beyond 19, okay? But when you start getting into pre-algebra and algebra, you'll need to know a few more beyond this. But for the most part, for what we're doing, this is as far as you need to go for now, okay? So let me walk you through my strategy. So as I create a factor tree, first thing I need to do, I need to look at this number 60 and ask myself, starting with the smallest prime number 2, does 2 divide into 60 without a remainder? Yes, it does. And since it does, I'm going to put that in my tree, and then I need to figure out what times 2 will give me 60. What is that? 30. Okay, now notice, is 30 prime or composite? It's composite, so we got to continue. So now I'm just going to look at the 30, and now I'm going to start back with the smallest prime number and work my way up. So 30, first smallest prime number is 2. Does 2 go into 30 without a remainder? Does it divide into 30? how many times? Okay, I hear 15, and I agree with you. Okay, now I'm just going to look at 15. Reset, go back to the smallest prime number. Does the smallest prime number 2 go into 15? Nope. It does not. So I got to go to the next prime number. Does 3 go into 15? Yes. It does. How many times does 3 go into 15? 5. It goes in there 5. And guess what? All the bottoms on all these branches on the bottom, are any of these bottom numbers composite? No, they're all prime. I'm done with my factor tree. Got it? Question? There's more than one way. I'm not going to get into the other methods yet, but do you understand this method? Okay. Now, if you do the prime factor tree correctly, even if yours doesn't look this way, you'll end up with the same result, which is being able to write the number as the product of primes. So what's 2 times 2? 4. And then 4 times 3? 12. And then 12 times 5? 16. Do you understand? So now I'm going to write all these numbers on the bottom of my factor tree. 2 times 2 times 3 times 5. Now sometimes they'll just say, hey, write as the product of primes. Sometimes they'll say, write as the product of primes using exponents. Okay? So if they want you to use exponents, you got to go a step further than this. Remember, exponents show you repeat multiplication. Are we multiplying a number more than once here? Yeah. What number is that? 2. Yep. So we have 2, and it's being multiplied how many times? Twice. So I could rewrite this so that it's 2 to the second power, or 2 squared, times 3 times 5, and that would be my answer. Do you understand? Okay, so questions. Yes, over here.
What if there's 2 of the same number? Like, for instance, let's say the number was 4, and we put 2 2s, or 30.
Right, so you're talking about another factor tree, it sounds like. So we'll talk about other factor trees a little later. Do you understand how we went from here to this step? Okay, yes?
So you're just taking 60 and going through all the prime numbers and seeing how many times you need it.
That will multiply to get that number back. Yes, Jayla? Well, then what you started out with was a prime number. Okay? So if your tree is just a prime number, then the number you started out with was a prime number. It would just been itself in 1. Okay? So now here's what I need you to do. Make the factor tree for 72 and write out its product of primes using exponents. And as soon as somebody has an answer they'd like to share, Taylor, what's your answer?
Well, I used exponents to know my answer.
That's fine. So what'd you get?
So I got 3 to the second power times 2.
So did you guys hear her answer? She said 72 is equal to 3 to the second power times 2 to the third power. So let's go through the background of how she got that. And you might have had a different method, but let's go ahead and walk through this. So 2 goes into 72 how many times? 36. And then restart. Does 2 go into 36? Yes. How many times? How many times? 18. Okay, reset. Does 2 go into 18? Yes. How many times? 9. Okay, and then we're going to reset. Does 2 go into 9? Nope. No. So we got to go to the next prime number. Does 3 go into 9? Yes. And how many times does 3 go into 9? 3 times, because 3 times 3 is 9. Now I'm going to write this as a product of primes. And here's the bottom numbers. They're all prime numbers, so I'm going to finish this up. And I'm going to first write this as 2 times 2 times 2 times 3 times 3. But it says to use exponents where possible. So if you notice, how many 2's do we have?
3.
I have 3 sets of 2's, so that's going to be 2 to the 3rd power. Times, how many 3's do I have? I have 2 sets of 3, so I'm multiplying 3 twice, so I'm going to put to the 2nd power squared. Do you guys see how we got that?
Yeah.
Yes. You probably got a different tree, but like I said, there's more than one method to factor these trees, to create these trees. But I'm just showing a method, and I'm going to show you why on the next slide when we do greatest common factor. Okay? So greatest means the largest, right?
Yeah.
Common means the same, and factor means number that divides into the number without a remainder, right? So we have 2 numbers. I need you to make the factor tree for these 2 numbers. So actually, just to speed things up, rows 1 through 3, I need you to make the factor tree for 24, and rows 4, 5, and 6, factor tree for 36, really quickly. Okay, rows 1 through 3. Can you guys tell me what's the first on the first branch here? 2 times what gives me 24? 12. Okay, so we're going to continue. 12's not prime. So can 2 go into 12? Rows 1 through 3? Yep, so we're going to go ahead. And what's that going to be? 2 times what is 12? 6. Okay, let's continue. 6 is not prime, so does 2 go into 6?
Yes.
Yep. How many times?
3.
Are we done?
Yeah.
We are. And how do we know we're done? Prime numbers are on all the bottom branches. Are we good? Okay, so rows 4 through 6. Does 2 go into 36?
Yes.
How many times? 18, very good. And then moving right along, does 2 go into 18? It does. How many times? 9, very good. Moving right along, does 2 go into 9? No, so what number are we going to check it next? 3. And how many times does 3 go into 9? 3 times. And notice primes are on the bottom branches. We're done, right? Now we're going to write it in expanded form. So first of all, before I do that, who can tell me what the GCF is going to be? Does anybody know? Okay, let me show you the cookbook method of GCF now. List these primes. So I'm going to list these out, 24 and 36. Well, that equals, and don't use exponents when you're trying to find the GCF. You're going to see why. 2 times 2 times 2 times 3, right? And then 36 is 2 times 2 times 3 times 3. And now everywhere I have a match between the top and the bottom, I'm going to circle a pair. So do I have a 2 between the 24 and 36? Okay, go ahead and circle a pair. Okay. Now, do I have another 2 to go with this one? Okay, go ahead and circle a pair. Do I have a 3 to go with this 3? Yeah, I do. Do I have another 3 to go with this 3? No. And I don't have a 2, so that's it. I've made my pairs, but now I got to identify the pairs. What's in this pair? 2. What's in this pair?
2.
And what's in this last pair?
3.
And what's 2 times 2 times 3? 12. So guess what? The GCF of 24 and 36 equals 12. That is it. If you don't understand why that's true, I don't need you to understand. I just need you to understand the method to get the answer. Okay, so do you guys understand the cookbook method to get the GCF? Later, you'll eventually understand, but if you don't understand it right now, don't worry about it. Okay? So we know how to find the GCF every single time, right? Okay, and now you see why I had you do the tree the way you did? Because it organizes it so that you can check what your sets are, your pairs. Got it? Okay, what I need you to do, if you notice for the next problem, we already did 24. Do 16 and find the GCF of 16 and 24. We already did 24. You don't have to do it again. We already have the numbers we need for 24. We're done with that part. Do 16 so we can find the GCF of those two numbers. Okay, and the factor tree for 16 is pretty easy, so that shouldn't take you guys too long. Are you guys done with the factor tree for 16? Okay. Okay, what's on the first branch? 8 with 2, very good. So I got 2 over here. Here's my 8. Okay, let's continue because 8's not prime. So what's going to go on my branch? 2 and 4, very good. So I got 2 over here, and I got 4. And I got to continue because 4 is not prime, so let's continue. What goes on this branch? 2 and 2. And they're both prime, so I got 2 and 2. So 2 and 2. And so if I rewrite this, you guys know the steps now, right? Yep. So can somebody tell me what the GCF is? Nathan, what is it? Who got the GCF using my method? Tori? I got 8. She got 8. Did you guys get 8? Yep. Okay, so let me walk through what we just did up here again with this next problem. So 16 and 24, we're going to use what we got for 24 earlier. We saw that was 2 times 2 times 2 times 3. And 16 is 2 times 2 times 2 times 2. And if we circle up our pairs, I got a set of 2's here. I got a set of 2's here. I get a set of 2's here. And then I'm out, right? So identify what's in each of my sets. I got a 2 here, a 2 here, and a 2 here. And then 2 times 2 times 2 is what? 8. So my GCF of 16 and 24 equals 8. Are we good? Okay, that's the end of my lesson. We just got one more slide to go through. How is a factor different from a multiple? Who can share with the class how they're different? Lola?
So a factor is something that a number can be divided into.
Nice, perfect.
And
And what's the remainder going to be?
and the remainder would be 0.
Okay, nice. And what about multiple?
So the multiple is multiply. So you can a multiple would be a number that would multiply evenly into.
You're really close. Let me go ahead and show you the answer. You're really, really close. You're like, I would probably give your response like an 8 out of 10. You're super, super close. Let me show you a 10 out of 10 response. A factor is a whole number that divides another whole number with a remainder of 0. A multiple of a number is the product of the number and another whole number, right? Because like I gave you 3, 6, 9. So 3 times 1 is 3. 3 times 2 is 6. You guys understand what multiples are? Okay, next problem. Which numbers are factors of all even numbers? All even numbers have these as factors. Do you guys know it, class? 2 and 1. Very good. Okay, next problem. What is the only even prime number? Class, you guys know this? 2. Very good. And then last part. I need you to tell me if 29 is prime or composite. Prime? What are the factors? Are there more than 2 factors? Okay, prime. 28, prime or composite? Good. 27, prime or composite? Composite. 9, 3, 27. There's more. Prime or composite? Okay. Okay, I hope you enjoyed the lesson. That is it. Homework tonight. Make sure you get the homework done.